Now that we've gone over some of the ways that we can use ShaderFX for environment art, we're going to take a look at how we can leverage it for visual effects. In this video, I'm going to show you how to make a simple animated fire effect and render that to a flipbook texture, ideal for lower spec projects like mobile games. The technique we're going to use to create the shader, however, can be used for a wide range of games, demanding different performance requirements from iPhone to console development. So let's jump right in. As an effects artist, one of the most versatile tools we have available to us is UV distortion. Using a black and white mask, we can manipulate the points on a texture map into some cool looking patterns, which we can then animate and get some interesting life to our sprites. We're going to be using this for our fire effect. First, I'm going to create an example so that you can get an idea of what the UV distortion is actually doing and how we'll leverage it for our fire effect. So I'm just going to create a plane here, so polygon primitives and plane. Just going to drag that out, change its size, just make it 10 by 10. I'm going to rotate it here 90 degrees, recenter it, make sure that my hardware texturing is on. Then I'm going to open up Hypershade, create a new ShaderFX shader, and apply that to our mesh here. And I'm just going to name our ShaderFX shader Distort UV Example. Close down Hypershade and open up ShaderFX. So inside of Photoshop, I have our masks underscore RGB PNG file, which I'll include with the video files. And essentially this is just an RGB packed texture, which means that in the red, green, and blue channel I have three different black and white texture maps, and this is a great way to preserve some memory, especially when you're just using some very simple noise textures or something like that. So we're going to be using the blue channel here to give our example of UV distortion. So I'm going to jump back into Maya here, and I'm just going to go ahead and create a texture. So right click, textures, texture map, and I'm just going to want to grab that RGB texture mask that I have. So under images I have masks, and I'm just going to grab that. So next I'm going to create a UV set, so under inputs common UV set. So we're going to be adding our blue channel of our texture map here into our UV set, and of course the blue channel is a float value and our UV set is a float 2 value, so we are going to have to do some massaging of the texture map data in order to get that to work together properly. So to do that, we're just going to drop down a vector construct under values, and we're going to grab the blue channel of our texture map, plug that into the X, and the blue channel of our texture map again, and plug that into the Y, and this will result in a nice float 2 value. One of the most common pitfalls when using UV distortion is having the effect come off way too strong. This typically happens when your texture map uses the full range of values from 0 to 255. So to combat that, we're just going to drop down a multiply with a float value, so math multiply. And we're just going to grab a float, so under values float, and we're going to multiply our float times our float 2 of our vector construct here. And this float is going to become UV distortion strength. We're going to bring it down to 0.5 for now, and we're also going to enable the input from Maya here. I'm going to move these over to the side. And I'm going to create a math add here. Now we want to add our texture map back into our UV set. So I'm just going to grab the UV out here, plug that into the first value on our add, and grab our multiply and plug that into the second value on our add. And now we can take a look at what's going on. So if you just hit the preview button, you can see that we have this green and red gradient with some cloudy texture going on here. And if we just enable the preview on our UV set as well, and you can see that we're transitioning from our smooth gradient here in the UV set to our gradient with a bit of a cloudy overlay into our add here. If I jump into Photoshop, I can show you where that gradient's coming from. So I'm just going to create a 512 texture here. Then I'm going to go into our gradient tool, make sure that I'm going from black to white. I'm going to go to our red channel, drag out a gradient, go to our green channel, drag out another gradient. I'm going to fill our blue channel with black. I can go back to our RGB. You can see that we have that green to red gradient here. Essentially, in our red channel, we have our U values. If you think of black as 0 and white as 1, you're transitioning from 0 to 1 here. And then the same goes with our green for our V values. You have 0 at the bottom of the V here, and 1 at the top of the V here. So now we can add overlays on top of our gradient here, which will distort the positioning of our 0 to 1 values and change the coordinates of where our texture map is being drawn. So I can do that here in Photoshop by just adding a layer, doing a filter, render clouds, filling our blue channel with black, and now I can make sure I'm back in RGB and set our layer style here to linear dodge add. And if I adjust the opacity a little bit, bring it down about 30%, you can see that we've started to manipulate the coordinates of this UV set. So now I'm going to jump back into my LT so I can show you how we can use some of that coordinate distortion and plug that into our texture maps. So instead of using a texture map, we're going to drop down a checkerboard pattern here. So under Patterns, Checker 2D, go ahead and create that. We'll need to create 2 color nodes, so Values, Color, drop that down, do a copy and paste. I'm going to change the first one's color to white here, and the second one's color to black. And plug those into the Checker 2D node and collapse those down for now. Then we're just going to grab our add operations result and plug that into the UV of our checker. You can turn on the preview. We are going to want to change the scale of our UVs going into our checkered 2D here. So we're simply just going to multiply, so math multiply, by a float value, so values float. And just plug that in, and I'm going to change mine to 5. Now I can grab the result and plug that into the checker 2D. So now our checker 2D is tiling. I'm just going to move these over, and I want to grab the output of our color here and plug that into the emissive on our surface shader. And now we can close down ShaderFX and take a look at our plane here. So it might be difficult to see exactly what's happened to our checkerboard texture here, but as I bring the UV distortion strength down closer back to 0, you'll start to see that the regular UVs are being used once again. And as I bring the strength up again, you can start to see that there's some cloudy action going on in the distortion here. And as I bring it all the way back up to 0.5, you can start to see how that turns into a very cool effect. We can then go into ShaderFX and add a panner to our texture map to make it animated. So I'm just going to drop down a panner node. So under Textures, grab the UV panner node, drop that down. Now we can take the end of our multiply here, plug that into our UV panner, and plug the panned UV back into our checkerboard 2D. If I turn on my range slider and time slider here, as I play the animation, the distortion starts to animate, and you can start to imagine how we're going to be leveraging that for our fire effect. So now we can get started with our flame effect. I'm just going to jump over to Photoshop here and show you the texture that we're going to be UV distorting. It's called flame_01.png. This texture I generated in another application using a fluid simulation. But you can download very similar textures on something like CG Textures or TurboSquid. But I will be including this in the video, so you can feel free to go ahead and use this one for now. So I'm going to go back into Maya. I'm going to open up Hypershade and create a new ShaderFX shader. And I'm going to name this Turbulent Fire_01. I'm just going to make sure I save my scene, so save scene as, and this is just going to be Turbulent Fire 02. And now we can open up ShaderFX, close down Hypershade, make the screen a little bit bigger. We can drop down our first texture map. So under Textures, grab the texture map node. We're going to rename it to Fire Sprite. And we'll just grab our My Texture path here, go into Images, and grab our flame_01.png. And so we can see what's going on in our shader graph better, I'm just going to click on the preview window here and bring up a larger picture for that. And for now I can just grab the output color of our fire sprite and plug that into the emissive on our surface shader. So now we can start to set up our UV distortion. So I'm just going to go over here and I'm going to drop down a inputs common UV set. And then I want to grab a new texture map. So under textures, texture map, and we're going to name this distortion noise. And then I'm going to navigate to our masks RGB PNG, just hit open. So now we're going to grab the output of our UV set and plug that into the input of our distortion noise. And if you remember what we talked about before, we're going to want to drop down a multiply to decrease some of the distortion of our mask here. So I'm just going to grab a multiply and a float value, so under values float. And we'll name this distortion strength. I'm going to put the default value to 0.75, and we'll plug our float into the multiply and just grab the green channel on our distortion noise and plug that into the multiply. If I just go over to Photoshop here, you can see that the green channel here is this wispy cloud texture, and that's going to look good for the distortion of our fire. So back in my LT, we can expand the preview of our multiply here and get a general sense of what's happening. And of course we want this to animate. So we're going to use a UV panner. So between the UV set and the distortion noise texture, make some room. And we're going to want to go for textures, UV panner, and drop that down. Then we can grab the output of our UV set, plug that into the input of our UV panner, and then grab the panned UV output and plug that back into our distortion. And make sure that under settings, play animated shaders is on. And now we can see inside of ShaderFX that the texture here is doing a nice pan. It's probably a little bit too fast right now, so I'm just going to drop the speed down to 0.25 in the U and V, just for now. So like I mentioned before, we're going to want to create a float 2 from our noise distortion here in order to get that into our UV input on our sprite here. So to do this, we're going to drop down a values vector construct. And we can grab the result here and plug that into the Y of our vector construct. And I'll just turn on the preview. So of course right now our vector construct is showing a value of 1 in the X and Z, which is giving us this purple texture. And what we're looking for is that red and green texture that we looked at before. So of course we're going to want to drop down a float value, set that to 0, and plug that into our Z here. And that way we can get a better sense of our U and V float 2 value as opposed to a float 3 in the preview window here. So we could just grab the result of our multiply here and plug that into the X, whoops, and that'll give us the kind of distortion that we talked about with the noise before. But for this example with our fire, it's going to be better if we can pan at 2 different speeds on the X and Y. So to do that, we're just going to copy our setup here and alter our UV panner and plug that into the X. So I'm just going to delete this connection, and we're going to create a group. So I'm just going to left click and drag and select our setup here and go to group, create group. I'm going to name this node Y distortion. Whoops. And now we're going to dive into our group here, because we want to grab the distortion strength variable and put that outside of our group so that we can control the strength of the X and Y at the same time as opposed to doing them independently. So to do this, we're just going to grab the value input of our multiply here and plug that into the any 0 on the left here of our group. And that'll create a new value input on our group here. And if you navigate over to your attributes editor here, so we haven't really talked about the attributes on our group node here, but for now we're going to be focusing on the active socket and the active socket label, which allows us to define what the words are here on our input. The active socket indicates the position on the group that we're speaking to. So in this case, 0 is indicating the first input, and we're going to want to rename it. So active socket label, we can change that just by typing in here distortion strength input and hitting enter, and that will rename the value on our input here. So we can now just grab our distortion strength node here, copy it by doing a Control-C, exiting the group, and doing a Control-V. And your graph will turn red here because we are missing an input inside of our group on the multiply here. Nothing's connected on the outside of our group. But if we just grab the output of our float and plug that into the input of our group here, everything will go back to normal. And this is a pretty great way to keep everything organized and to use kind of global variables between your groups. Now we can just grab our Y distortion group, do a Control-C and a Control-V, move that over, and we're going to rename this one X distortion. Hit enter. We can grab the distortion strength float and plug that into the input on our group here, and just grab that result, and you can plug that into the X on our vector construct here. And you do get a yellow here because X and Y are being panned at the same speed. But if you jump into the group, you can change the panner, and I will just change mine to negative 0.125 on the U and negative 0.25 on the V. We'll adjust these later to get a better look, but for now this is going to work. And if I exit the group here, okay, so I did have to pause the video for a second because there is a problem with the UV panner node in this version of my LT. As you can see, we have two different speeds in our UV panner. This one's doing a negative, and on our Y distortion this one is doing a positive pan. And on our construct here, they're both panning at the same speed, and this is because the current version of the UV panner is using shared UVs as opposed to unshared UVs. So there is a fix to this, and I will make sure to include that file with the downloads for this video. I'm just going to close down ShaderFX and show you what we've got here. So there's a file that I will be including called uvpannerfix.grp. And inside of your program files under Autodesk MyLT, presets, ShaderFX, and then system nodes, you're going to want to grab the downloaded file here and just copy it to your system nodes folder. And that'll add the UV Panner fix here. And if we reopen MyLT, open up our project again, open up ShaderFX, you now see that under Hardware Shader Nodes Textures we have the UV Panner Fix node. So we're going to drop that down inside of each one of our groups. So Textures, UV Panner Fix. And I'm just going to replug our UV set into the input, grab the panned UV output, and plug that into our distortion. And we can delete this one, the old one. And if we just type these back in, so negative 0.125 and negative 0.25, go into our Y distortion group and drop down the fixed UV panner node, delete the old one, wire that back in, adjust the values to 0.25 and 0.25. We can exit the group now, and you should be able to see, make sure that your play animated shaders is on. The X and Y noise is actually moving at a different speed. So just make sure that you download that file and replace that, and you should be good to go. Now that we've done that, we can move everything over here. Drop down a math add node. Grab the float2 output of our vector construct here, plug that into the first value on our add, and we can drop down a inputs common UV set and plug that into the second value on our add and bring up the preview. And as you can see, we're getting some animated noise inside of our UVs. We're just going to grab the result here and plug that into the input of our fire sprite. As you can see in our fire sprite here, we are getting distortion across the entirety of the texture map. We only want it around the center near the flames, and we don't really want it to tile like this. So the first thing to do to fix the tiling issue here, if we delete the input of our add operation here and just drop down a inputs common UV set, do a multiply with a float value, plug those in, grab the result, plug that into the UV, change our float value to something like 2. It's going to start to repeat our texture map outside the 0 to 1 space, and that's not really what we want. We want it to stop the black values. So if you just select your texture map and go to the attributes editor, grab the sampler UV coordinate option here and change that from wrap to clamp, and then on the V do the same, change that from wrap to clamp. So now outside the 0 to 1 space, it will just grab the last pixel color and repeat that. And this is good because when we grab our result of our add here and plug that back in, you can see that around the texture map we're no longer getting that tile, which is good. The next thing that we want to address here is to create a mask so that the flame distortion is only happening at the top part of the flame and not near the bottom, and that'll get rid of the movement of our flame texture here to the left hand corner. So to do this, we're going to create a mask procedurally with a couple of gradients inside of ShaderFX. So let's do that. First thing that I'm going to do is just delete all of these extra nodes we've got here, and I'm going to move over down to this corner, and I'm going to drop down a UV set. So under inputs common, UV set. And like we talked about before with the UV set, this is actually just 2 gradients. We have one that goes from the 0 to the 1 on the U, and 0 to the 1 on the V. So I'm just going to jump into Photoshop and kind of show you what we want to accomplish. We have here our emulated UV set with the gradients in the red and green channels. And essentially what we're going to want to do is, if I create a new layer and hide that one, we want to create a black and white gradient that goes from right or left to right, and then another one that goes from right to left, and essentially multiply those together, and then create another one that goes from top to bottom like that, and multiply that one also. And now if we combine these 2 gradients into one layer and bring up a levels, we're going to want to get something that looks vaguely like this here. And if I just copy and paste our flame into our multiply gradient, you can see that if I turn these on and off, it's essentially allowing us to create a mask of just the bottom part of the flame. And obviously this is what we're going to use to interpolate between the static UVs on the bottom and the distortion UVs on the top. And we're going to be able to create this gradient with the UV set. So I'll just jump back into my LT and we can get started doing that. So now we want to grab the gradient that goes from 0 to 1 on the horizontal axis. And we're going to do that by just dropping down a vector component. So under values, vector component node, and just grab the UV output of our UV set, plug that into the vector input on our vector component. And then we want to create a multiply. So under shader nodes, math, multiply. And essentially what we want to do is grab the X value here, put that into the first multiply. And then we want to flip it so that we have the 0 to 1 on the horizontal axis going from right to left. So to do that, we can just grab a math invert 1 minus, grab the X output, and plug that into the other input on our multiply. And if I bring up the preview, this is essentially what we had in Photoshop before we did the levels command. And to do a similar thing like the levels command, we're going to drop down a power. So under math, pow, grab the result of our multiply, plug that into the X. Then we're going to grab a float, so values float, plug that into the Y, turn on our preview here, and we can adjust our float to what we think is going to look good. 0.5 looks pretty good to me for now. I'm just going to move these over to the side. And the last thing that we want to do is grab a gradient that goes from top to bottom. So to do this, we're going to create a multiply, grab the result of our power, and we can go back to our vector component, grab the Y output, and plug that into the multiply. If I bring up the preview window, it is inverse, so we do have to drop down another 1 minus, so I'm just going to copy paste this one, grab the Y, plug that into the first input on the second 1 minus, grab the result and plug that into the multiply. Now we have our mask. Using the UV set and the vector component nodes together, we can create some really cheap masks. You can do this via texture, but I like to do it here because I've got a lot of control and I don't have to keep switching in between Photoshop and ShaderFX to get the right type of gradient. The next thing that we're going to want to do is integrate this back into our graph. So I'm just going to grab these and move them over. Maybe create a group from them, so create group, and we'll call this mask. And just dive back into your group here and make sure that you grab the result of your last multiply, drop that onto the any on the left hand side of your group node. You can hit exit again. Now we've got that result exposed. And we're just going to want to drop down a multiply, so math multiply. And we want to mask our vector construct here of our distortion. So just grab the float 2, plug that into the first part of the multiply, and grab the result of our mask and plug that into the second input on our multiply. And now we can grab that result and plug that into our add. And you can see that up around the corners on the sides here, we've just got the basic UV set. And in the center we have the distorted UVs. The mask is not as clear as I had hoped it would be, so we're just going to jump into our group here and do a few adjustments. The first thing that I want to do is drop down a multiply between the power and this multiply here. So math multiply. We're going to plug the power into the first part of our multiply, and we're going to drop down another float value. Plug that into the multiply, plug the result back into our final multiply, and I'm going to set this value to maybe 2. And I want to go back to our power float input here and possibly make that 0.8 instead of 0.5. Now if we exit the group, that's starting to look a little bit better. Unfortunately, the preview window on our fire sprite texture here isn't exactly what it looks like in the viewport. So to really tweak the adjustment of that mask, we're going to want to go back into the viewport and drop down a plane, so polygon primitives plane, and I'll just adjust this a little bit, make the width and height 10. Rotate it 90 degrees. And recenter it. Now we can go into Hypershade and just drop that onto our plane. Looks like that didn't work. Just right click and hold on your turbulent fire shader and just grab the assign material selection. Now we can close down Hypershade. And the last thing that we're going to do to scale the sprite back into the plane is just adjust the UVs on our plane here. So we can close down ShaderFX, select your object, then go to Edit UVs, UV Texture Editor. Go to UV mode and select all the UVs for that plane, and just scale them up a little bit. And move it down. Maybe a little bit more, and that looks like it should be good. We can close down the UV editor, go back into object mode, turn off the grid, under show grid, and if I just show my range and time slider here, I can go ahead and play that. So it looks like it's going a little bit fast. I did mention that we can adjust our panner speeds to get a better look, so let's do that now. Back inside of our shader, open ShaderFX. On our X distortion, we're going to jump in there, grab the panner, and we want to adjust our speed. I found that 0.1 on the U is pretty good. On the V, I had 1. And then for our Y distortion, for our panner, I had 0.5 on the U and 0.25 on the V. Now we can close ShaderFX and play that animation again. Looks like it's going a little bit fast. We'll want to increase our time slider here. Let's adjust this to maybe 120 and 120. Go ahead and play that. And then just make sure to right click on your timeline, go to playback speed, and enable real time. And now when we rewind and play the track, it looks pretty good. So that's about all the time we have for our first video here. In the second video, we're going to take a look at rendering this effect to a flipbook for use in your engine, and then we'll talk about some things that you can add to your shader to make it more versatile in production. So I hope you enjoyed that, and I'll see you next time.